Our next functional group is called an aldehyde. Aldehydes have a very particular structure, and they're responsible for a lot of very sweet smelling smells, such as the smell of cinnamon or vanilla or even lilacs. Those are all aldehydes. An aldehyde is a very particular functional group in that it is always a terminating end. We can't continue on after an aldehyde, and it can't really function as a side chain. An aldehyde is really a carbon, double bonded to an oxygen, single bonded to a hydrogen, and then having a carbon chain, which we represent with the letter R. That just means that it continues off somewhere else. Whenever we see that, we'll see it like this. There's our carbon, there's our double bonded oxygen, there's our hydrogen. That is going to be our aldehyde. Now for priority naming, this one is going to function a little differently. We're going to put it into the priority. However, there's going to be a particular trait about it. So first, let's put it in. It's coming in at number 3. This is going to be an aldehyde. It's going to get the suffix al. Okay. And if it does get beat out, which is very rare, it will get the prefix formal. However, if an aldehyde is not going to be beat out, because it is a terminating end, it has such a high priority that it automatically makes the carbon in the aldehyde number 1. Okay? Let's look at what I mean by that. Now, for any other molecule, I would treat the functional group here as my number 1 carbon, just like normal. So let's go ahead and name that. So this is going to be a 1, 2, 3, 4, 5. So that's going to be pent. No double bonds in sight. And then an aldehyde, so al. Pentanal. There we go. This one here, again, I'm going to start at 1 for my aldehyde. So it's going to be a 1, 2, 3, 4, 5. Once again, pent, this time with a double bond, N, then al. Nice and straightforward. One thing we're missing, though, we need to identify where that double bond is. So this is going to be pent 2 N al. All right. So far, so good. Straightforward. But looking at this last one, this is an interesting compound. Now, if you notice with me here, I've got a 1, 2, 3, 4, 5, 6, 7, 8, 9 carbon chain. But the rules of the aldehyde are that it takes such high priority that we say, I don't care how long this chain is, that's my number 1 carbon. I don't care where else you've got stuff, unless it's something that beats out the priority of an aldehyde, which we haven't seen yet. This is my number 1 carbon. So whatever we do, this has to be number 1. So now this is going to be number 2, and then now we just need to figure out which one's longer here. 2, 3, 4, 5, 6, or 3, 4, 5, 6. Horse apiece, let's go this way. Oh, actually, this one should be, because it has another side chain. So it has another constituent on it. So this should be 3, 4, 5, 6. So here we've got a 6 carbon chain with the aldehyde in it. That means this is going to be hex, no double bonds, and al. And then we just identify our functional groups, or our side chains. So we've got a 1, 2, 3, 4 here. 2, 3, 4. And we've got a 1, 2 here. So I've got a butyl group on carbon 2. It's going to come first. and then I've got an ethyl group on carbon 3. So even though this had a longer carbon chain elsewhere, that aldehyde is carbon number 1, and so I end up with a butyl group instead of a nonane carbon chain. All right? That should make sense.